Alright, we're looking at 5.3, problem number 15. This is an applied physics problem using average value of a function. So this problem says if a vehicle averages 30 miles an hour on a 180-mile road trip, so 30 miles an hour is V1 on a 180-mile road trip, that's x1, and then returns over the same 180 miles at a rate of 60 miles per hour, so our rate 2, our velocity 2 is 60 miles an hour, and our distance 2 is the same 180. So the first thing we're going to do here is we're going to convert everything to time, because physics usually depends on time. So x1, so if you take velocity times time, you get distance, and the reason why is because if velocity is in miles per hour, and time is in hours, the hours cancel and what you end up with is miles. So if that's true, then it's also true that the amount of time it takes is equal to the distance divided by the velocity. Right, if I said it's 60 miles to get there, and you knew you were driving at 60 miles an hour, you would take the 60 miles divided by the 60 miles an hour, and you'd find the time required was 1 hour. So I'm going to solve for the velocity of the first trip, or I'm solving for the time of the first trip. The distance was 180 miles, and the velocity was 30 miles per hour. So time 1 equals 180 divided 30, which is 6. And that's our time final, because we know we started the trip at time 0, and it took us 6 hours to get there. So let's go ahead and graph that out. So on my x-axis, I'm going to do it in terms of time in hours, and my y-axis is going to be in terms of distance. Actually, let's make it in terms of velocity. Okay, so v is our y-axis, and so in this case, we know that our velocity was a constant rate from time equals 0 to time equals 6. 1, 2, 3, 4, 5, 6. So from time equals 0 hours to 6 hours, we were traveling at a constant 30 miles an hour. And we know that when we finished, we were, we were going 30 miles an hour the whole time. So that's constant, which means that the whole time we were going 30 miles an hour all the way across. Alright, and then on the return trip, we'll take the second distance, which is the same 180 miles, divided by the second velocity, which is 60, and that'll give us our second time. Our second time is 180 divided 60, and that's 3. So if it took us 3 hours to get back, then that would be 1, 2, 3 on top of 6. So from 6 to 9, we were traveling at a constant 60 miles an hour. Now the area inside of these blocks represents 180 miles. Both of them do, because both journeys covered 180 miles. This journey took longer in time, so it took less velocity in space. And this journey took less time, so it took higher velocity in space. But both of the areas is 180 and 180, representing the 180 miles that were driven. So the first question asks, on the first trip, what's the average velocity? Alright, so on the first trip, what's the average velocity? Well, we're going, so you remember average velocity is 1 over b minus a from a to b of f of t dt, in this case, because we're using time. And so b in our case for the first part is 6 hours. 1 over 6 minus, our starting was 0, so our a is 0. From 0 to 6 hours of our function of t, which is velocity of t, is 30 dt. So when we take our, when we simplify and take our antiderivative, we'll get 30t going from 0 to 6 hours. And so we'll plug this in. 1/6 times 30 times 6 minus 0. Because when we plug in 0, it's just going to give us 0. So 180 divided 6, that gives us 30. Which makes sense, right? Because if you're traveling the same rate from here to there, and we're interested in the average, it ought to be the exact same as all the individual ones, because we were at a constant speed. So that makes sense, and that's the answer to the first one. Then the question for the second one is, what about for the second part of the journey? What was the average velocity of the second part? And you could probably guess right away it's going to be 60, because we were going 60 miles an hour the whole time. So it makes sense that it'd be 60, but let's write it out. So 1 over b minus a. B in this case is 9 hours, and a is 6 hours. And we're going from 6 hours to 9 hours at a rate of 60 miles per hour with respect to t. And when we solve for this one, we'll end up with 1 over 3 from 6 to 9 of the antiderivative, which is 60t, which equals 1 over 3 times 60 times 9 minus 60 times 6, which is 360. Okay, so 540 minus 360 divided 3 gives us the expected result of 60 miles per hour. Alright, so we know that on the first trip our average, let me write this down, on our first trip our average velocity 1 average was 30 miles per hour, and our velocity on part of the trip 2 average was 60 miles per hour. Now the question is, what was the average velocity of the whole trip? And the trick here is that you might think you could just add 30 and 60 and divide by 2, because that's how you would typically average things that weren't weighted. However, in time, both of these trips are weighted in time. So in other words, this trip took significantly longer than this trip. This one took, as a matter of fact, out of the whole trip, if we did a fraction of the whole trip, this fraction right here, the fraction that this part of the trip took up, would be 6 out of 9, right? Because the trip took 9 hours, and this section took 6 of those 9 hours, which leaves a remainder of 3/9 for the latter part of the trip. And so these are our weightings in time. And so V1 average was 30 times its weight, right? We went 30 for 6/9 of the trip. So we times it by 6/9, plus we went 60 miles an hour for 3/9 of the trip. So those are our weightings, and they give weight to the amount of time it took. So we'll go ahead and take 30 times 6 divided 9, that's 20, plus 60 times 3 divided 9, that's also 20. So 40 miles per hour was our total average for the whole trip. And it kind of makes sense, because if you're going 30 miles an hour for longer, you would expect that the average would be closer to 30 miles an hour. And so that's how we figure out the weightings, instead of just adding them together and dividing by 2, because they represent different quantities of the trip, and so we have to take that into account. Well, I hope this was helpful, and I'll see you next video.